Introduction to ADFS. So Federation Services is a fairly complex topic, and there's a lot to go over, and we're not going to be able to touch on everything. It would take way more time than we have. But let's start with some of the more basic information, and we'll go on from there. And once we have an understanding of some of the components involved and how the data flows from one system to another, then we'll get more into the exam objectives. So here we have a simple diagram of Active Directory Federation Services. And this diagram isn't to be taken literally. It's a very, very basic overview of some of the topics we're going to be talking about just for understanding purposes. And we have two organizations here. We have an account partner organization and we have a resource partner organization. And we have a user who's on a client in the account partner organization who wants to access resources or an application that's sitting in the resource partner organization. And for our purposes, the resource partner organization is going to be Office 365, and the account partner organization is going to be our local on-premise Active Directory. Now, with Federation Services, we don't want to have to authenticate to Office 365. We want to use our internal Active Directory authentication and then have Office 365 trust that we are who we say we are. Now, in order for that to happen, there must be a trust between Office 365 and local Active Directory. So when we want to access the resources in Office 365, we're not going to be sending it credentials like username and password. We're going to be sending it a token and claims or claim statements. And you could say that the claims or claim statements are part of the token, but regardless, the token plus the claims equal the information that we're sending to Office 365. And a claims or claim statement is really just a bunch of local attributes from our Active Directory that just has additional information other than just our regular identity. Now, the token and the claims were generated by our Active Directory Federation Services and handed off to us, which we then send to Office 365. As long as Office 365 trusts the Federation server, then they're going to accept the token and the claim statement that we give them, because not only does it have our ID and our claims, but it's also signed by a certificate that's installed on the Federation server, and the application server or Office 365 can check that. Now, if the Federation server needs to validate our credentials or is forced to use forms-based authentication, it's going to ask us for our username and password, which it'll then check with the domain controller to make sure we are who we say we are. Now, sometimes the client knows to go directly to the Federation server, but a lot of times it's just asking to log into the resource partner, and the resource partner has to be aware that there's this trust and say, you know what, I'm not supposed to receive your credentials. You need to be directed over to the Federation server. And then the Federation server can ask for the credentials if necessary, check them with the domain controller, issue a token, sign that token, pass the token and the claim statement back to the client, and then the client sends that signed token and claims to the application server. The application server will then check the token to make sure it's signed by the correct certificate, and then allow the user in. And that's pretty much the workflow for many of the situations we're going to be talking about. But there's a lot of terminology that gets thrown around, specifically for the names of the servers or the parties. For example, the Federation server, since it's providing a token and it's also providing claims, it's known as the claims provider or the secure token service, and it's often referred to by either of these depending on the context. The domain controller is considered the identity provider, and it's also the attribute store. So when the Federation builds its claims, it's doing so with data that it finds in the attribute store, which is Active Directory. The application server that's relying on the claims and tokens issued by the Federation server is called the relying party. Now we're going to see some of these workflows in action. We'll start off with a typical Office 365 portal login. So here's a typical Active Directory Federation Services environment. On the internal network, we have our internal users or clients, and then on the servers, we have our domain controllers. We've got our Federation servers, which can either be a single standalone server or can be in a farm or clustered. And we have our Azure AD Connect, because we're still going to be synchronizing a lot of data from our on-premise environment to Office 365, so that's still required. And then we have our firewall to the internet. And between the firewall and the internet, we have our DMZ or perimeter network. And this is an environment that devices can be plugged into that can have separate rules depending on whether they're talking to the internal network or the external network such as the internet. The thing about a DMZ or perimeter network is that it allows you to put servers closer to the internet so that there's more ports open and there's less security with the internet than there is internally. These devices are essentially exposed to the internet. But the communication between these devices and your internal network is very, very limited. Therefore, nothing on the internet needs to speak directly with anything on your internal network. It uses the devices on the perimeter network, and the perimeter network can then forward information to the private network if that's what you'd like. In this case, we have WAPs, or Web Application Proxies, in the DMZ, and this is what external users in Office 365 will be communicating with, since it can't reach the Federation servers directly. So initially, we'll look at internal clients, and if an internal client wants to access Office 365, they'll type in portal.office365 or portal.office.com into their web browser, and they'll be brought to the Office 365 login page. And they'll type in their username. Now, if we've designated the pfslab.com to be a federated domain, which is a switch we have to flip in Office 365, it will determine that it cannot authenticate us anymore, that we must authenticate with our Federation server. So it'll send a redirect, or a 302, back to the client, back to the browser, and it'll tell it what URL to go to. And this URL will contain the address for our Federation server, as well as a bunch of information that it's going to send to identify the session info. And that's so that later on, when we actually go to connect again, it'll remember the original session we tried to initiate. So the client at this point will be redirected to the Federation server, which right here is sts.pfslab.com. And note here that the sts.pfslab.com represents the Federation service name. We're presented with a login page that looks similar but a little different from the Office 365 page, and we put our username and password in. That username and password is then sent to Active Directory domain controllers, and a response with claims information for the user is sent back to the Federation servers. The Federation servers then once again redirect the client back to Office 365, only this time the URL includes token and claims information. And this URL also contains the original session info. Upon redirection, Office 365 takes the claims and token information as well as the session information to determine whether or not the token is valid and signed by the correct server. If it is, it lets the user in. And the format of this token and claims and session info is called SAML, S-A-M-L, or Security Assertion Markup Language. And the ability for a client to access Office 365 by specifying a URL that has all this information is called the SAML assertion. Next thing you know, the user's logged into Office 365. The situation is very similar with external users as well. They try to access Office 365. Office 365 recognizes that we're dealing with a federated domain and will send a redirection to the same URL. Only this time, the external users can't access the Federation server directly because it's on the other side of the firewall. But a DNS lookup from outside the organization will resolve to the proxy servers instead of the Federation servers, so that URL brings them to the proxies. They're provided the same forms-based authentication page where they put in their username and password, and then the proxy will then send that information to the Federation server, which will check it against Active Directory. If it's valid, the Federation server will pass back to the proxy the token and claims information, who will then send it back to the external users. So the external users wind up with the same URL, only they spoke to the proxy and the proxy spoke to the Federation server, instead of the internal clients who could speak directly to the Federation server. The external users are then redirected to that URL, and the SAML assertion happens. So for this to work, the proxies and the Federation server have to answer to the same DNS name, have the same Federation service name, and also have the same certificate installed. Now, there are a lot of different workflows and a lot of different scenarios, but I'll show you just a couple more so you can see how flexible the Federation service can be when configured correctly. In this case, we're going to be dealing with Windows Integrated Authentication. And the workflow is very similar. We travel to Office 365. We're redirected to the Federation server. This time, however, when we go to the Federation server, it recognizes that since we're a domain-joined computer and we're already authenticated to Active Directory, it doesn't even require us to put in our username and password. And it can actually use Windows Integrated Authentication or Pass-Through Authentication, and then just issue us our token and claims in a redirection URL that we then send to Office 365. Beginning with ADFS 3.0, which shipped with Windows 2012 R2, we now have a new authentication type called Modern Authentication. And we've seen this before, but we didn't really speak about what it was. So in this case, we'll be using Outlook 2016 to connect to Exchange Online. And as you can see, when we open Office 2016, we're given a pop-up here. And this pop-up is a white rectangular box with a logo at the top. When we see this box, and we've seen it when we connected through the Azure AD PowerShell too, we're dealing with Modern Authentication, which is using the OAuth or Open Authentication Protocol. It's still considered a forms-based authentication, but instead of the form being delivered by the Federation server, this pop-up is provided by a DLL that's installed locally on the internal client, but the workflow is very similar. We put in our username, and it immediately checks with the application server that it's trying to access whether or not it's a federated domain. If it is, it then redirects right inside the pop-up to change the form to match that of the Federation server login page. We'll then continue filling out our password, and that information is sent to the Federation servers, which authenticates to Active Directory, who then sends a token back to the application. The difference here is that it's not a SAML token, it's a JSON Web Token or JWT. It's just a different type of token. Once that application has the token, it can then send the token directly to the Exchange server. Now, by default, modern authentication is not enabled for Outlook 2016 and Exchange Online, so you won't see this type of login unless you turn it on. And then lastly, we'll talk about something called basic authentication. And basic authentication is a little bit different. So here we're still using Outlook, but let's say we're using an older version of Outlook. And Outlook itself has its own credential box that it assumes it's going to send the username and password directly to the Exchange server. However, we're using Exchange Online. So when we put our username and password in, it's sending it directly to Exchange Online, which we're not supposed to do. The whole point of Active Directory Federation services is that we don't need to send credentials to Office 365 or have them leave the local environment at all. But in this case, because the application is not aware of Federation services, it just sends that credentials to the cloud anyway. For this scenario, Exchange actually sends the username and password to the proxy server, and then the proxy server can then forward it to the Federation server for checking with Active Directory. In order for this to work, the web application proxy needs to be operating in something called pass-through authentication mode, which we'll talk about when we go set it up. The rest of the process is very similar. The Federation servers will check with Active Directory to make sure the credentials are correct, and then issue a token and claims rules which it passes back to the proxy. The proxy then will give it to Exchange, who will then allow the login and the application will connect. So this was just a primer, and we're going to be talking about a lot of these more in depth, but the key takeaways here are that the Federation server generates signed tokens and claims or claim statements. The client, or the proxy in the case of basic authentication, sends the tokens and the claims via SAML or JWT. SAML and JWT use the URL to pass that token and claims info. The relying parties, in this case Office 365, receives the tokens for ID and authentication. Also, the internal clients use the Federation server directly, while external clients and the web application servers talk to the web proxy. Both the internal Federation server and the web application proxy must answer to the same name. Active Directory is referred to as the identity provider and also acts as the attribute store, while the Federation server is often called the STS or Secure Token Service. And that becomes important because later, as we'll see, a lot of the Federation server names in documentation is referred to as STS. The last thing we'll talk about is ADFS versions. Originally, Windows 2008 and Windows 2008 R2 shipped with ADFS versions 1.0 and 1.1. You don't see these around too much anymore, but version 2.0 was made available as a download for them. With Windows 2012 came version 2.1, which was very trivial upgrades to 2.0. Now with Windows 2012 R2, we have our ADFS version 3, and there have been a lot of changes. We're going to be working with version 3, but it's important that we understand what changed from version 2, especially since the latest exam objectives have only just updated for version 3, and they still reference version 2 a lot, so it's good that we know both. For version 3, the web application proxy server replaces just the ADFS web proxy, and we'll talk about the differences between those when we go to install them. Also, we don't require IIS anymore. With ADFS version 2 and 2.1, IIS was a necessary role on the ADFS and the proxy servers. This is no longer true, and we can still get to certain redirected web page endpoints without IIS. Also, version 3 is the first one to support that modern authentication with OpenAuth version 2 and ADAL. With that comes support for Azure multi-factor authentication. Now, multi-factor authentication was possible in version 2 and 2.1, but it required third-party software. Also, in the older versions, you were allowed to either create a standalone Federation server or create a farm. The problem with creating a standalone is that you would never be able to convert it to a farm later on. You were stuck using one server for the duration. So a lot of people just chose farm anyway, even if they were only deploying a single server with no high availability. With ADFS 3.0, the ability to install a standalone server has been removed, and now you can only install farms, even if you're planning on only using a single server. Okay, let's take a look at an Office 365 portal login with ADFS. So this demo is going to be pretty quick. I just want to show the difference between logging in through Active Directory Federation services from an external client and from an internal client. So right now we're on an external client. I'm on my desktop, and I'm going to type in my lab login name. Now, as soon as I finish typing this and move away from this field, it should recognize that this username belongs to a federated domain, and it will redirect us to a pfslab.com address, and you'll see the URL will change. So I'm just going to hit Tab, and you can see it says redirecting. If we look up at the URL, it's going to go to adfs.pfslab.com. Now, ADFS is my Federation Services name, so that is what the DNS and the SSL certificate are issued to. So we'll finish with our password here. And what you'll see is because we're using what's called WS-Fed, which is the type of sign-in or authentication method that we're using with portal logins here, it's going to issue a SAML token, which it's going to deposit in the URL along with the Office 365 portal login URL, and then it'll log us in automatically. And it's going to be quick, so we'll pause it when we go to record it, but just watch when I hit sign in, the URL will change to Office 365, and there'll be a long URL at the end, which will be the SAML token. Right up. It was so fast. I'm hoping I catch it in editing, but that's basically what it was. So now we've logged in, and our passwords went to our ADFS lab server, our adfs.pfs lab server, not to Office 365. Okay, so let's try the same thing from an internal client. So we'll come into our lab environment. This time I'm going to use Internet Explorer, and I'll show you why in a minute. Well, here's one thing. So it already knows who we are here. I'm going to say forget us for now. And let's come in and we'll say that we're adreyer@pfslab.com. And again, it's going to redirect us as soon as we move away. However, when we're on the external client, we were resolving to a proxy. Now we're going to be talking to the Federation server directly. So we'll come here to a redirect. And as you can see, it didn't even prompt us for credentials. That's because we used integrated Windows authentication or Windows integrated authentication. So Internet Explorer has the ability to check your identity, to verify that you are who you say you are, or to pass along a request for Windows integrated authentication, which the Federation server can grant, and we weren't prompted for credentials. And last but not least, just to show you here, let's go ahead and do an NS lookup internally on adfs.pfslab.com, and we'll see that it's an internal address of 172.31, so that's internal. If I come out to my desktop here, and we'll do the same thing from an external client, adfs.pfslab.com, we see we get a external address, 34.194.236.32. So as we can see, we have these two resolving to different addresses, but we were presented with the same login screen. Well, actually, we didn't see the login screen with the internal client, but if we had, just real quick to show you here, we'll come to a portal.office.com. I'm using Chrome now, and Chrome won't give us the integrated Windows authentication, but here is now us using on the internal network, so this is the internal Federation server. It's the exact same login. And we can customize this. We could change the graphic. We could change this info. This was something that we specified during the install. We'll see when we go to do the installation. But it's the same login whether you're external or internal, even though we're hitting different IPs. Okay, so that's it for this demo. Next up, ADFS namespaces and certificates.